Welcome to Summarize Science. Today, we explore a fascinating study on how researchers are using artificial intelligence to understand the economic map of Europe. National statistical institutes usually check their data for errors by looking at individual numbers, like checking if a region's unemployment is suspiciously high or low. However, the researchers behind this paper argue that these traditional methods often miss the bigger picture. A region might not have extreme numbers in any one category, but it might have a very strange combination of stats across several different areas. To solve this, the study explores unsupervised machine learning, which allows a computer to find patterns without being told exactly what to look for. This approach is specifically designed to find structural anomalies or regions that just do not follow the typical European trend. The researchers focused on four main indicators: wealth per person, unemployment rates, education levels, and population density. They gathered data from the year 2022 for 260 different regions across the European Union and candidate countries like Turkey. 5 different math-based detection methods were tested and compared to see which regions stood out the most. One interesting method, called an isolation forest, works by trying to isolate each data point through a series of random splits. The easier it is for the computer to separate a region from all the others, the more likely it is to be a structural anomaly. To make sure the results were reliable, the researchers decided that a region would only be flagged if at least 3 of the 5 methods agreed. This ensemble rule helps filter out random noise and focuses on the most significant economic differences. Out of all the regions studied, only 11 were identified as true structural anomalies. The results showed that these machine learning methods are much better at finding complex patterns than old-school statistical rules. The findings highlight 2 very different types of unusual regions. On one hand, the AI found high-performing capital cities like Brussels, Vienna, Berlin, and Prague. These cities combine massive wealth with very high population densities and unique job markets. Looking at the data visualizations on page 10, you can see how these areas have unique combinations of high unemployment and lower education levels. On the other hand, several regions in southern Spain, Hungary, and Slovakia were also flagged as anomalies for these reasons. The researchers emphasize that being an anomaly does not mean the data is incorrect or that there is an error. Instead, it shows that these places have a unique economic profile that deviates from the dominant European pattern. These findings confirm that multivariate detection highlights structural divergence rather than just extreme individual values. In summary, the researchers demonstrated that AI can act as a powerful early warning system for official statistics. By spotting these trends early, governments can better understand regional differences and prioritize where to focus their policy efforts. This study suggests that AI can complement traditional validation tools to make data more useful for decision-makers. In the future, this technology could be expanded to look at how regions change over time rather than just a single snapshot. This work represents a significant step toward modernizing how we monitor the economic health of various territories.